So, in last class we talk about k-means clustering approach. So, that is the part of partitional clustering approach. As I said, there are many clustering approaches, and this clustering approach can be classified into two main categories. One is partitional clustering, another is the hierarchical clustering. Partitional clustering create a flat clustering or a single clustering, whereas hierarchical clustering, it creates the multiple clustering, a sequence of clustering. Okay. So, that is we will cover today. So, hierarchical clustering method creates a sequence of clustering, that is each clustering is denoted by pi 1, pi 2, pi 3 and pi I for the given data set. It can produce inherent nested structure of the cluster in a data. So, like family tree. Okay. So, this is a hierarchical structure. So, similarly, if in a data set there is some hierarchical structure, to capture that hierarchical structure, this clustering algorithm is the good idea to apply. Okay. So, we move forward. This hierarchical clustering approach can be obtained, as you understand that, as I said, is it form the hierarchy, and this hierarchy of the data or of the cluster can be formed in two ways. One is something called the divisive approach. Okay. Divisive approach means you start with one cluster containing all the points. Say suppose you have 1000 points. So, consider this entire data set is a single cluster, and then you divide the data set into two clusters, then from two cluster to three clusters. In the next clustering you form the another 4 cluster and so on, until at each step split a cluster until each cluster contain a single point. So, you started with let us say 10 points, now single cluster, then you will have a 2 cluster. Obviously, number of points will remain same, that will be divided between 2 clusters. Now, from 2 to it will form let us say 3 clusters, and then from 3 it will form 4 clusters and so on, until or unless each cluster contain a single point. So, this is something called the divisive approach. So, we talk about k-means variant, that is bisecting k-mean. So, bisecting k-mean is typical example of divisive approach. So, you started with a big cluster and then divide into 2, and then next level you divide it into 3 and so on. Another approach, and that is the most popular approach, is called the agglomerative approach. What is that? So, instead of considering the entire data set into a cluster, you consider that each point is a cluster. Okay. So, start with the points as individual clusters, or merge the closest pair of cluster until only number of cluster become 1. So, it is on the other way around. I will explain more detail. So, you start with individual points is a cluster. Let us say there are 4 points only. So, you start individual point is a cluster, and then what you do it. So, start with the point as individual cluster, merge the closest pair of cluster until the number of cluster become 1s. Okay. So, then you merge this one. So, let us say you merge this one 2 and then become 1. So, all point become a single cluster. So, here one example here. Say we have initially the points, there are 5 points P1, P2, P3, P4, P5. So, each individual point you consider this is one cluster, this is another cluster, this is another cluster, this is another cluster, and this is another clusters. Okay. So, this is a clustering where each cluster contains a single point. This is one clustering. Now, you move it. So, P2, P3 is merged. So, P2, P3 will form a cluster and all other remain same. This is another clustering. Now, in the next step you merge with P2, P3 with P4. So, P2, P3 will merge with P4. So, this is another cluster and this is another cluster. So, this clustering, this is another clustering. So, it has 3 clusters. Now, you merge with P2, P3, P4, this is one, and another is you merge with P1 and P5. So, you merge with P1 and P5. So, there are 2 clusters. Now, you merge these 2 clusters, you will get a clustering. So, let us say pi 5. and that consists, oh, it is already there. So, pi phi will form the single cluster, as you can see this is a clusters and all points here. So, if you see from the down to up, this is something called the agglomerative approach. Now, same thing you can think of. So, initially it has all points consisting, all point are in a single cluster. So, this is the number of cluster is here 1. Now, this cluster divided into another 2 clusters. So, let us say pi 5 to pi 4 another clustering. So, p 1 p 5 in one cluster, another is p 2 p 3 p 4 is another cluster. So, here number of cluster is 2, here number of cluster is 3, here number of cluster is 4 and here number of cluster is 5. As you understand, last one and the first one is trivial. Okay. So, there is no need to do anything, but in between you need to have some algorithm to partition the data, a systematic approach. But in general what happened, actually divisive approach is not very popular, is the on the other way around, the agglomerative approach is popular. What is agglomerative approach? We start with individual point is a cluster and then we merge the clusters and then we reach to the that a situation where number of cluster is 1. So, therefore, we only study the agglomerative approach. So, next we will see how agglomerative approach works. So, here this is something called the bottom up, because each individual point was in a clusters and then we merge these two closest clusters and then maybe we can merge these two closest clusters first and then this one and then you merge it here and so on. Okay. This structure is something called the dendogram, as we have seen earlier. This structure is called the dendogram. This tree like structure is called the dendogram. This is the output of the hierarchical clustering approach. Now, we will study this algorithm, that is the agglomerative approach, very carefully. Okay. How do we proceed? We will be given the data set without label, that we know, that is because we are talking about the unsupervised learning. Okay. So, what is the first step? Compute distance matrix for the data set. What is distance matrix? Suppose in the data set you have the points, let us say p 1, p 2, p 3, p 4 and p 5. So, you have 5 points. So, what is the task? Task is to find the distance matrix. So, distance matrix is nothing but it represents the distance from one point to the all other points. So, that I think I cover in somewhere here in during the class of the data, distance matrix I probably told. So, here there are 5 points. So, then from each point to all other points you have to 5 distance, you have to find the distance. So, we compute a matrix of size, because there are 5 points, it is a square matrix of size 5 cross 5. Okay. And what you do it? So, from point p 1 to all other points p 2, p 3, p 4, p 5 we find distance from p 1 to p, obviously it is 0. So, similarly p 2 to all other points you find distance, p 3 to all other point distance, p 4 and p 5 and so on. So, this is something called the distance matrix. So, first step is done, compute the distance matrix for the data set. Now, let each data point be a cluster, because we are considering the agglomerative approach. So, agglomerative approach that we learn is each data point will be considered as singleton cluster. So, if there are n points in the data, so then at the first step you will have the n cluster. Now, this is important. What is that? Merge two closest clusters. You merge two closest clusters and update the distance matrix. This distance matrix basically represent the distance from, I said one point to one point to all other points, this is right. It is not only that, this distance matrix represent the distance from one cluster to all other clusters. Once I said each point is a cluster. So, please note that each point itself is a cluster. So, this distance matrix itself represent the cluster to cluster distance. From one cluster, say P1 is a point as well as a singleton cluster. So, distance from P1 to the all other cluster it represents, similarly P2, P3 and P4. So, and we have to repeat this step. What are those steps? Merge at each step two closest clusters. So, at each step we are merging two closest clusters, that means each step we are losing one cluster. So, initially there are n number of clusters. So, when you merge two closest clusters, so this will be 1. So, therefore, number of cluster will reduce to n minus 1. So, next step it will be n minus 2 and next step it will be n minus 3, and then you reach a point where the number of cluster is 1. So, that is the agglomerative approach. So, what you do it in this step? Merge the two closest clusters. This is very important, the two closest clusters. And second step, the update the distance matrix. Distance matrix will represent the distance from one cluster to another cluster. After merging two clusters, there will be change of the distance between one cluster to others. So, therefore, you have to update the distance matrix. Merge the two closest cluster, how do you find? So, you have to search the matrix and you have to find the wherever the least entry, and then that entry is nothing but the distance between two clusters. Okay, there are some advanced method, but this is the way we can do. So, what is the then in summary, what is that? Compute first, you compute the distance matrix. Each point is considered as a cluster. So, this distance matrix itself represent the distance from one cluster to other clusters, and then you go repeatedly you do for the n minus 1 times. Each time what you do it, you merge the two closest clusters and update the distance matrix. So, here if you see the original slide, so there is a mark closest cluster. How do you find the two closest clusters? And obviously update the distance matrix. So, we have to understand these two parts very carefully. So, how do we merge the two closest cluster? Before knowing the how to merge the two closest cluster, closest means minimum distance cluster, that is obviously it is known. But before that we should know how to compute the distance from one cluster to another cluster. We know how to compute the distance between 2 points. Okay? So, using Euclidean distance we can compute. So, but thing is that how to compute the distance from one cluster to another cluster, each cluster consists of a group of points here. You have also a set of points. How do you compute distance from cluster C1 to C2? So, that will be the distance between one cluster to another cluster. So, different way we can compute the distance from one cluster to another cluster. So, this is the way. There are three major ways that we can compute the distance, and each technique is something called is, if we compute the distance in this strategy, then we say is that agglomerative approach we say is the single link or single linkage approach. If we compute the distance in this fashion, then we will say that agglomerative approach is called the complete linkage method. Otherwise, if you compute the distance in this fashion, then we will say is that agglomerative approach is the average link. So, there are three algorithms, one is single linkage hierarchical method, another is complete linkage, another is average linkage. Only you change the distance measure, otherwise basic structure of the algorithm remains same, that I covered in the last slide. So, what is the distance from one group to another group? So, this is the single linkage distance. So, you have the points here, you have the another points here, another cluster. What will be the distance between two cluster here? Distance is nothing but the distance from the two closest point, from each point is taken from the different clusters. So, then what you have to do? You have to compute the distance from this point to the all other points. You have to compute distance from the all other points. So, you have to compute one point to the all other points distance, and wherever the distance is minimum, that will be the distance from the two closest clusters. So, that is something called the single linkage algorithm. So, more mathematical, it is the minimum of the all distances here, where each point is taken from the two different clusters. So, next is complete linkage or complete link. Complete link is just opposite of the single link. It is the maximum distance between the 2 points. So, here it was minimum, here it is maximum. And next is the average link. What is average link? you compute the all pairwise distances from this point to the all other points, you compute the all pairwise distances and you take the average distance. So, therefore, average if there is m points and n points. So, how many distance you have to compute m into n and you take the average this one. So, from one cluster to all other clusters, from one point to the all other points, from one point to the all other points you sum up and you take the average. So, that will be the average linkage. Basically, I taught 3 algorithms. One is single linkage, another is complete linkage and another is the average linkage or average linkage. But you have to remember the previous part, these remain same. Say suppose if I ask you apply the single linkage or complete linkage or average linkage, these step will remain same. So, first step is you have to compute the distance matrix and then each data point will be a clusters and you merge the 2 closest clusters. So, closest clusters means what? So, you have the distance matrix here. So, you find the 2 closest cluster here. So, this is the minimum distance, okay, and you merge these 2 clusters. Now, when you update it, you update the distance matrix according to the distance formula. When you merge it, always you choose the closest one. There are 2 difference here. When you merge the 2 closest cluster, it is irrespective of the any algorithm. Always you take the minimum distance clusters, but when you update the distance matrix, that time you have to compute the distance from one cluster to another clusters and then you have to choose, if it is a single link, you take the distance from the 2 points, 2 closest point. If you consider the what is called is the complete linkage, you take the farthest distance. One example I can give you here. Let us say you have a point here 1, 2, 3, you have a point here 4, 5, 6. Now, instead of that, if I say here this is one point, here one point, and let us say here you have point here, and here also you have a point here, here and here. Now, if you use the single linkage, what will be the distance from 2 clusters? It is the distance cluster from C1 to C2. If you use the maximum, if you use the complete linkage, so this will be the distance. So, let us say this is the farthest point. Okay, so, that will be the distance. Okay. Now, you have another cluster here. So, let us say here. So, from here to minimum distance will be here and let us say minimum distance will be here. So, we are considering let us say single linkage. Okay. Let us say this distance is 2, this distance is 1 and this distance is 3. Now, you have to merge the 2 clusters. So, which one will be merged? C1 and C3, because this distance is minimum. Okay. So, this is a single linkage algorithm, but always it is irrespective of any clustering approach, always you choose the minimum distance. One example, if I say again, let us say you compute the complete linkage. So, the complete linkage distance this will be let us say 6. From here to, so this is the 2 points, let us say this will be the farthest one. So, this will be 5 and this will be the let us say farthest distance. So, this will be let us say 5, 4, 3. Okay. Now, which cluster will be merged? Among these distance you have to find the minimum closest one. So, which one is to be merged? So, this C1 and C3 will be merged. While computing distance you use those formula, but when you merge the clusters you have to choose always the minimum distance, not the you have to merge C1 and C2, that is not the right, because it is said the merge the 2 closest clusters. Now, we will talk about the complexity. So, what will be the complexity for the agglomerative approach? What is the step? Compute the distance matrix for the data set for 1 to 1 other points. So, so complexity will be order of n square. So, forget the space complexity. So, time complexity will order of n square. Okay. So, for this one it will be order of n square time complexity, and space complexity also will be the order of n square, because you have to keep the in the matrix. Now, this is the step until first one point. So, there are n cluster until in a single cluster. So, then how many this step, how many time you do it? N minus 1 time, and then what you have to merge the two closest clusters and update the distance matrix. So, how many time you merge the closest clusters? N minus 1 time. And what is the complexity of merging? If it is n, then we say is the total complexity is order of n square. If it is n square, how do you merge? Find the two closest cluster. So, if without any further data structure, what you can do it? So, you have to merge the two closest cluster. How do you merge it? You have to find the all elements here. So, there are order n square element, order of n square element. So, searching a minimum points, it will take the order of n square time. Okay. So, each time you have to find the minimum. So, order of n square time. So, for this step itself we will take order of n square time, and what you have to do? You have to update the distance matrix. Again distance matrix at most it can take again order of n square time, and this has to be done for n time. So, therefore, complexity will be order of n cube if you do not use any other data structure. Here we say the time complexity is order of n square. How do you reach the time complexity is order of n square? With one example here. So, this is the distance matrix has already been computed between 5 points. Okay. So, here we work out here. As we know that distance is Euclidean distance is symmetric. So, this point will be 2.3 and this point will be 3.4, this point will be 1.2, this point will be 3.7 and this will be 2.6, this will be 1.8, this will be 4.2. I think I am doing some 1, 2, 3, 4, 5. Okay. Next here is this is 4.2, this is 0.7. So, here 4.4. Okay, because this is symmetric. Now, what is the objective? Objective to apply the single linkage clustering on this data. We got the distance matrix here. So, this is the distance matrix. Okay, we got here, and the complexity of this method will be order of time complexity will be order of n square. How it will be achieved? So, what we do it here? We need to have some extra data structure. What is this data structure? So, while computing the distance from one point to the all other points, obviously we must have computed the distance. 1 to 1 is 0, 1 to 2 2.3, 1 to 3 3.4, 1 to 4 1.2, 1 to 5 3.7. While computing distance from one to other points, we are writing it here. Along with that, we find which point is the closest to 1. Okay. So, we write it here. So, one closest point is here is which one is 4. Obviously, 1 to 1 you have to exclude this one. So, 1 to 4 is the closest, right. So, you write this value 1.2 and another value you write it here another, and which point is closest. So, it is a fourth point. So, this is we say is the minimum, this is we say is the index. Okay. Now, in the second, so this is 1.2. Now, similarly, when you compute the distance from 2 to the all other points, you compute the minimum which except this 0, do not consider 0. Which one is minimum? 1.8. So, you write this is 1.8 and 1.8 is again 4. Next is this is 0.7 is minimum, you write 0.7 and 0.7 is nothing but the 5. Next is the fourth row. So, which one will be minimum? 1.2, right. So, this is minimum is 1.2 and this is 1, and then fifth which one is minimum? 0.7, right. So, this is 0.7 and then 3. Okay. Now, what is that algorithm earlier we talked about? That is the two step algorithm here. We are concentrating, we computed the distance matrix. Now, merge the two closest clusters. Okay. So, this is the step we have to find. So, how do you find the two closest cluster? In other algorithm you have to find the distance matrix and wherever the minimum. So, minimum is here. So, you search the n square number of points. Now, in this technique what you do, instead of searching in the matrix, what we do it, we will search in the, we will search this array. This array size is not n square, this array size is n. So, therefore, searching time will be reduced from n square to n. So, we will start searching from here, where is the minimum? So, minimum is here, and we will see this is minimum appeared with 3, right, with third row, and then we will get the two cluster, 3 will merge with 5. So, we got the 3 and 5th should be merged. Okay. So, therefore, next stage we have to update the distance matrix. First is you find the two closest cluster, merge the two closest cluster, we merge it. After searching order of n elements, we got this is the minimum and that is the value of the minimum, and it should be merged with 5. So, 3 and 5 should be merged. And what is the next step? You have to update the distance matrix. So, now here is important point. So, 3 is here, 5 is here, let us say 1 is here, 2 is here and 4, 1, 2, 3, 4, 5. So, there are 5 points. Now, when we merge the cluster 3 and 5, so we merge the 3 and 5, there is no change of the distance between the cluster 1 and 2 and 2 and 4. Other clusters distance from the other cluster there is no change. So, therefore, this distance matrix no need to change any other row apart from the row 3 and 5 or column 3 and 5. Please understand. So, when we merge this 3 and 5, there is no change of the distance from 1 to 2. Obviously, there will be change of the distance from the 3 5 to 1 or 3 5 to 2 or 3 5 to 4, that we will take care, but there is no change of the distance from 1 to 2 or 2 to 4. Now, thing is that we know the distance. So, how do you update this distance matrix? We know the distance from 1 to 3, we know the distance from 2 to 3, we know the distance from 4 to 3, because this is everything we will get from the distance matrix. And when we merge these two clusters, because it is a single linkage, so what will happen? We know the distance from 1 to 3 and we know the distance from 1 to 5. So, what will be the cluster distance from after merging? Whichever is the minimum. So, then ideally what we do it? We point out this row and this fifth row, and we compute distance from 1 to 3 fifth, which one is minimum, that will be the distance from 3 to 5 to the cluster 1. You got my point. What do we do it? Let us say here this will remain same, 1, 2, 3, all other entry will remain same. Now we are updating it. While updating, we will only look into 2 rows and 2 columns. What are those 2 rows? Row number 3 and row number 5, because we are merging 3 and 5. Similarly, we look into only the row number 3, column number 3 and column number 5. Let us say 3 and 5. Now, 3 and 5, what is the distance? 3.4 and 3.7. So, now what will be the distance from one cluster to the merged cluster 3 and 5? Obviously, minimum 3 and 3.4. So, then we will write 3.5. So, instead of 3.5, we will write here 3.4. Why it is not written? Because we are only saying the upper triangular matrix, because it is a symmetric one. Now, you move again to the next, distance from 3 to 2 is 2.6 and distance from 5 to 2 is 4.2. So, which one is the minimum? Minimum is 2, 3 and 5, it will be 4.6, yeah, because this was 4.6. So, now you compute the distance from 3 to 1 is 2.6 and 5 to 2 is 3 to 2 is 2.6 and 5 to 2 is 4.6. So, which one is minimum? 2.6. So, distance from 3 to 5 to 2 will be 2.6, and while computing this distance row wise, no need to compute the distance on column wise, because it is a symmetric. So, 3.5 and therefore, 3.4 and 2.6 2.6, and because we merge the cluster 3 and 5. So, there is no need of keeping the fifth row here. So, therefore, there is no fifth row here, and not only that, fifth column also will not be there, because you are merging, that will form a single cluster. Now, similarly, what you do it 3/5 to 3/5 no meaning. So, because this is again 3 to 4 is 4.2 and 5 to 4 is 4.2. So, minimum 4.4. So, minimum is 4.2. So, minimum is 4.2. So, updation is complete. For updation, what is the complexity? You are seeing the 2 rows, you are seeing the 2 rows only. Okay. So, that is the constant number of row, and then for you are observing n elements. So, complexity will be order of n. So, therefore, each merging and updation is taking order of n, and then you have to do for the n number of step. So, obviously, complexity will be order of n square. So, after this one, what you have to do it again, you have to do the same, you have to update this matrix, this matrix. So, you have to find the minimum while computing this distance, not separately, while computing this distance you change, there is change or not. So, you find the minimum is 1.2, here minimum is 1.8, here minimum is 2.6 and so on. So, instead of searching again for the merging this T cluster original matrix, you only search this array, and therefore, complexity is order of n, and then obviously, you choose it, and to identify whether it is merged, you can put some sign. So, flag you can put, so that can be avoided. Okay. So, again computing. So, let us say you merge 3 and 5. So, obviously, this fifth row will not be there, fifth position will not be there, and then you merge it. So, you put some values here. Okay. So, that way if you compute it, then complexity will be order of n square, and then next step you find it, and then here, and then finally, you get the dendogram here. So, first step we merge 3 and 5 and distance, minimum distance was 0.7. Next step it was minimum is 1 and 4, minimum distance was 1.2, distance between two cluster was 1.2. Next you merge 1 4 with 2, distance was 1.2, and then finally 2 cluster merge is 2.6.